All right, so now we are into our topic on graphing sinusoidal functions, okay, under transformation. So you did see this last year. It is a bit of a review from grade 11. Um, so I can identify the values of A, K, P, and Q, so very, very important, and then I can apply it to a sinusoidal function or a periodic function and graph the resulting transformation. So quite a bit of information there. So I always teach graphing using the mapping for the college stream. And I mean, no, there's going to be people watching this saying that it's a slow process, and I agree. It's not the most efficient, but it works every time. All right. So this is what I recommend. We have our base sinusoidal function, and it needs to look like this. Our mapping takes our coordinates, so our original coordinates, all right, and because I'm using the sine graph, all right, I'm using sine, we start off with 0, 0, and then the next point would be 90 and 1, and then 180 and 0. All right, so those are three coordinates. You can pick any three coordinates in order. All right, and what we want to do is move them from original to transformed. And again, people who are watching this and saying mapping is a slow process, there's much faster out there. I agree. However, this one is bulletproof. Students, do not mess this up, especially when you're not doing thousands and thousands of graphs. Speed's not an issue. It's process, which is the most important. So what's the mapping to move us over here? Okay, the mapping, I'm going to do it just down below here. So what you do in order to move those points over, your original point, which we'll call xy, so whatever coordinate you're looking at, will now become x over k plus p, and then ay plus q. Let's talk about that for 1 second here. So x is our horizontal values. K, from last lesson, we talked about K is a horizontal stretch or compression or period. So it affects your value of X. P is the horizontal shift. So this is how K and P influence the value X. And the next one, A is a vertical stretch or compression, Q is a vertical translation. So this is how A and Q affect the value Y. So if you can tell me K, P, A, and Q and plug it into this, then you take the X from here and you substitute it in, take the Y from here, substitute it in, you get your new point. End of story. Works every time. All right, it's golden. I'm pointing at you with both fingers like guns. All right, you know, hey, Fonz, you wouldn't get the Fonz reference, so I don't know what the current one would be. Anyhow, so there you go. So let's move on and do an application. So you got the grid printed out hopefully for you when you did the, when you printed out the note. So y equals 2 plus 3 cos 2, blah, 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 blah. Say it really quick. It's got to be in the right format. Now, most of you will be able to pull out the information in the format that it's in. I'm going to rearrange it. So there's 3 cos 2 x minus 45 plus 2. So I've just rearranged it. So in class, normally we would play this game for a couple minutes. I would put a bunch of equations up there, and you need to be able to give me these pieces of information. If you can give me these pieces of information, you can do a transformation. If you do the transformation, you can graph any graph. So hopefully everyone understands that A is what multiplies the cos function, so it would be 3. K is inside the trig function, but it's in front of the brackets, so it would be a 2. P is what's inside the brackets, but remember, the sign gets switched when we pull the value out, so it would be plus 45. And Q is the last number that appears. It is the vertical shift, and it is also positive too. So there we go. So from our mapping on the other page, and I'm just going to rewrite it, x over k plus p, ay plus q. We know that the transformation will be x divided by 2 plus 45 AY will be 3y plus 2. So now I need original coordinates to put through this machine to get new coordinates. All right? Original coordinates. I am using the coast graph. I'm going to switch to green. Okay? Coast. Coast starts at 1. So if I quickly put the y scale on here, 1, 2, 3, and 4. -2, 3, -4. My coordinates would be, it's 0, 1. Then it goes at 90 degrees, it's 0. And 180, it's -1. So I take those 3 points as my originals. So I said, oops, 0, 1. Then I said 90, 0. And then I said 180, -1. So all of my x values, I'm going to divide them by 2 and then add 45. All right? So my new coordinates will be 0 divided by 2 is 0, plus 45 is 45. 90 divided by 2 is 45, plus 45 is 90. 180 divided by 2 is 90. 90 plus 45 is 135. The y values, okay? Each y value, multiply by 3 and add 2. So 3 times 1 is 3, plus 2 is 5. 0 times 3 is 3, plus 2 is 2. 3 times -1 is -3, plus 2, so that'd be -1. These are the location of where or how these 3 points got transferred. So they become, here is the original values. We've transformed them because of A, K, P, and Q. And now this is what they've become. They've mutated into this new function. So I'm going to graph those points in blue. So I've got the right grid here. Every block is 45 on the x-axis. I picked it for a reason. I'm going to stick with that. So 45 degrees and 5. Oh, it goes off my scale. Oh, what else is new? So anyway, it would be up there. 90 and 2. And 135. So that's just moving over 45 from the 90. So 135, -1. So right here. Okay, now the last part, the tricky part. If you remember this from the base coast graph, this was a crest, this was a midline, and the 180 minus 1, that was a trough. All right? They don't change. They remain crest, trough, midline. So that means that my crests are going to touch or go up to 5. All my troughs are going to go to -1. And it's going to be my new x-axis or new midline is right there. Now you just have to follow the pattern. All right? So I'll see if I can do this with the disappearing ink. Okay? Crest, midline, trough, midline, crest, midline, trough, midline. Okay? So I'll replace those. So now it goes back to the middle. Now it goes to the trough. I know it's 1 square apart because these first 2 points I calculated are a block apart. So that's the pattern I'm following. All right. So there we go. We want to graph it from -360 to 360. So I also have to work backwards here. So once you get the patterning down, it goes fairly quickly. There you go. Now you just need to connect the graph. Do it in reverse. Up and down. Up and down. Up and almost down. There you go. All done. Transform function. Works every time. Again, I got my shooting figures up at you. Gotcha. All right. That's all they want us to do is graph it. Moving on to the next one. Hey, K, P, and Q. Got to be able to pull them out. A is -2. K is 0.5. P would be -90. Q is going to be -3. All right. So, again, I'll show the mapping. X over K. You need to put this on your cheat sheet. Please don't forget. Okay. So X over 0.5 minus 9, because it would be plus p, but it's minus, 90. There's good job. Excellent work copying. There we go. Minus 90. A is negative 2y minus 3. There we go. Need to get some original points or original coordinates because they'll help me get my new ones. Okay, in green, I am dealing with my sine function. So it starts at 0, 1, 90 and 1, 180 and 0. All right. Do you have to pick those? Absolutely not. You can pick any three in order. I know I have a midpoint though. Okay, so this is in the midpoint. Then here I have a crest and back to a midpoint. So I just got to remember that. So the original coordinates, 0, 0, 91, and 180, 0. All right. Now, when you divide by 0.5, and you can confirm this with a calculator if you think I'm crazy, dividing by 0.5 is like doubling. It's like multiplying by 2. So I'm going to multiply by 2 and subtract 90. So first one will be negative 90. That was the easy one. Next one I'll have 180 because 90 divided by 0.5 is doubled. So it's 180. Take away 90. It's 90. 180 times 2 is 360. 360. Take away 90. Let me just see if I did that right. Yeah. So yeah, 180. So that'd be 360. Take away 90 is 270. And you can use a calculator to do this if you're not comfortable with it. Next one, negative 2 times 0 is 0. Take away 3. Negative 2. Take away 3 is negative 5. And 0. Take away 3 is negative 3. All right. So there are the new coordinates. So in blue, I'm going to plot them. Negative 90 down 3. 1, 2, 3. So here's my dot. So you actually see me draw something after a wait. 90 and negative 5. Of course, it goes off my graph. What else is new? 270 and negative 3. 1, 2, 3. All right. Now, remember, I said that we have to remember what each one represents. So midline. This was a crest. This was a midline. All right. Well, what's happened is that the graph has been flipped upside down. That negative 2, the A value up here, has made it actually this into a trough. All right. So it's actually our low point. So the distance or amplitude here is 2 squares. So that means my crest will be 2 squares above the midline, which means it'll be up here. Now, what's the pattern? So to go from, and I'll use my disappearing ink, to go from here to here, I had to go across 1, 2, 3, 4 squares across, down 2. Then I went 4 squares across, up 2, which means I'm going to go over 4 squares and up 2. So it's going to go off. Going the other way, though, 4 squares across, up 2. So that's where another point will be. So what's going to happen is that we're only going to get part of that curve. So it's going to look like that. And there we go. All right. So the negative amplitude changed my crest to a trough. So you can see this up here. See in the original graph how it was a crest. And then when I went to plot my new points, it was going the opposite direction. So that's what hinted to me that my trough has now become my crest has now become a trough. All right. So there we go. I believe I got one more example, so I'll do it in the final video here, and then you're all set to go. We're going to spend probably a day or two on the graphing in class, so if you have questions, please ask. And like I said, I'll do one more example so you have that.